All right, welcome to this explainer. Today, we are leaving Earth in the rearview mirror to look at a world that is going to completely shatter your expectations of planetary scale.
I mean, what if I told you there's a single mountain out there, a single volcano so unfathomably huge that its base could literally swallow the entire country of England? Okay, let's dive into this. We're exploring our closest celestial neighbor today, and its geography is, well, it's anything but ordinary.
Section 1. Meet the Red Planet, Earth's bizarre neighbor.
Now, you've probably noticed that iconic rusty hue up in the night sky. That's actually caused by iron-rich rocks covering the surface. But to really get Mars, we kind of have to look at what's familiar and then contrast it with what is totally alien. On one hand, it has a remarkably familiar 24-and-a-half-hour day, and it even experiences seasons. But step outside, and you are 142 million miles from the sun, completely enveloped in an incredibly thin, suffocating atmosphere made of almost pure carbon dioxide.
And just look up at the skies above it. Mars doesn't have a beautiful glowing moon like ours. Instead, it has two tiny, black, potato-shaped moons, Phobos and Deimos. Both of them are heavily cratered and blanketed in this thick layer of dust that's at least 3 feet deep. Astronomers actually suspect they might be ancient asteroids that just got captured by Mars's gravity a long time ago.
Section 2. A world of extremes, record-breaking geology.
Traveling from those dusty skies straight down to the solid ground, we find a violent history that honestly breaks all the rules of planetary scale. These dramatic valleys and absolute behemoth volcanoes were formed by 3 main forces. You have the sculpting power of water, ice, or wind, you have violent meteorite impacts, and you have massive tectonic shifts in the planet's crust. Now, what's really interesting about this is how that internal crust movement gave birth to some true geological monsters.
Which brings us to the number 3. I want you to just let that sink in for a second. 3. That is exactly how many times taller the largest volcano on Mars is compared to our own Mount Everest. It's insane.
Behold Olympus Mons, the largest volcano in the entire solar system. This is the monster that could swallow England. It reaches a staggering 16 miles high and features a 56-mile wide sunken crater at the summit. But you might be wondering, why on Earth, or rather, why on Mars, is it so massive? Well, here on Earth, our moving tectonic plates basically drag volcanoes away from their underground magma sources, which creates chains of smaller islands, kind of like Hawaii. But Mars's crust, it's mostly stationary. So Olympus Mons just sat parked over a massive hotspot for millions of years, continuously pumping out lava and growing to unimaginable, record-breaking heights.
And if the highest highs aren't quite enough for you, consider the lowest lows. When the surface of the young planet was stretched and split by internal tectonic movement billions of years ago, it created Valles Marineris. This gigantic scar runs right across the Martian equator. Get this, it is 2,500 miles long. To put that into perspective, that makes it 10 times longer and 5 times deeper than Earth's Grand Canyon. Absolutely wild.
Section 3. Dust, wind, and ice, the chaotic atmosphere.
So while the giant volcanoes are practically frozen in time, the atmosphere right above them is wildly chaotic. Mars might be a freezing, dry planet today, but high-level winds scream across the surface at up to 250 miles per hour. These furious winds kick up colossal clouds of orange-brown dust, rising 3,000 feet into the air. And these monster storms can literally blanket vast areas of the planet for months on end.
But, the wind also acts as a kind of subtle artist. There are massive patches of Martian sand with mesmerizing patterns that look almost like elaborate tattoos. These are carved by dust devils, which are spinning columns of rising air that tower up to 5 miles high. As they whirl across the plains, they sweep away the lighter red dust, revealing the darker, heavier sand lying just beneath.
And the extremes just keep going, right to the planet's poles. Mars actually has permanent ice caps, just like Earth, but they are fundamentally different from each other. The northern ice cap is about 1.8 miles thick and is made primarily of water ice. But check out the southern polar cap. It is much thicker and bitterly cold, plunging to a freezing negative 166 degrees Fahrenheit even during the Martian summer. Because of this intense, permanent cold, it's mostly made of frozen carbon dioxide.
Section 4. The search for water, following the rovers.
The presence of all that polar ice begs the ultimate question. Did this dusty, frozen planet ever have flowing liquid water? To find out, humanity has sent an incredible lineage of robotic explorers. We started with the Mariner 4 flyby back in 1964. Then Mariner 9 became the first orbiter in '71. followed by the historic Viking 1 landing in '76. And by 1997, the Mars Pathfinder delivered the very first successful rover, which completely revolutionized our hunt for clues on the surface.
And man, those rovers have found some astounding things. Take Endurance Crater, for example. It's a relatively small impact site, about 420 feet wide. In 2004, the Opportunity rover spent 6 whole months carefully navigating and analyzing the soil and rocks inside this very crater. And what it found, scattered around the area, was a fascinating little mystery.
Opportunity discovered thousands of tiny, dark gray pebbles scattered in the dust, which NASA affectionately nicknamed blueberries. These little spheres contain an iron-rich mineral called hematite. So why is this so crucial? Well, because here on Earth, hematite typically forms in bodies of liquid water, like lakes and hot springs. Finding a massive field of it on Mars is a huge, glowing signpost pointing to a watery past.
And the clues aren't just chemical, right? They're structural. You can clearly see deep gullies and channels running down from high cliffs into the craters below. To a geologist, these look exactly like features carved out by flowing rivers and liquid water cascading down mountainsides right here on Earth. Wind alone couldn't have shaped these specific cuts. Something had to flow.
And this brilliantly illustrates the enduring mystery of Mars. We have a planet that was once dynamic enough to rip open 2,500-mile canyons, shift its crust just enough to build volcanoes 3 times the height of Everest, and quite possibly host vast quantities of flowing liquid water that carved the landscape we see today.
It leaves us staring at a really profound question to wrap up our explainer. If a planet defined by such incredibly violent extremes, from suffocating carbon dioxide air to blistering 250-mile-per-hour dust storms, if a world like that once held flowing water, what other secrets are waiting to be discovered just beneath its red dust? It definitely makes you look up at that little orange dot in the night sky with a whole new sense of awe. Thanks for learning with me today.